Yes. One episode is enough for a basic introduction. Today we define the tensor product of a k-linear function and an L-linear function by writing down the formula directly and checking that it becomes a k plus L linear function. No commuting diagrams today. Everyone may breathe normally. Here is the setup. Let t be a k-linear function, and let s be an L-linear function. For this video, both maps are scalar valued, meaning their outputs lie in the field. That way we can multiply the outputs together without opening a whole new chapter of abstract machinery. The definition is extremely direct. The tensor product T tensor S is the function of k plus L variables obtained by feeding the first k variables into T, the last L variables into S, and then multiplying the two outputs. That is it. Sometimes the cleanest definition is just the one that stops talking at the right moment. The main point is that T tensor S is not just some random formula. It is actually k plus L linear. So the tensor product of a k-linear function and an L-linear function naturally produces a k plus L linear function. Conveniently enough, the notation was not lying to us for once. For one of the first k slots, linearity comes entirely from T. Because S just sits there as a constant scalar factor, additivity and homogeneity follow immediately. The same argument works for every one of the first k slots. Which is nice because proving them one by one would be a spectacular waste of everybody's afternoon. For one of the last L slots, the situation is reversed. Now T is the constant scalar factor, and linearity comes from S. Again we get additivity and homogeneity immediately. So T tensor S is linear in each of the last L slots as well. Put both parts together, and we are done. Miraculously, the proof is exactly as straightforward as it looked. The simplest example is when both maps are just linear functionals. Then phi tensor psi sends v, w to phi of v times psi of w. That gives a bilinear function. So tensor products already show up at the very first non-trivial level. Because apparently the universe does enjoy efficient recycling. Here is a slightly larger example. If B is bilinear and phi is linear, then B tensor phi is a 3-linear function given by B of v1, v2 times phi of w. Nothing mysterious happened. We simply combined a 2-linear map and a 1-linear map to get a 3-linear map. Exactly as advertised. Astonishingly honest notation. One quick warning. Multilinearity is automatic, but extra properties need more care. If T and S are symmetric or alternating in their own groups of variables, that does not automatically mean T tensor S is symmetric or alternating across all k plus L slots. Together, mathematics loves giving you a nice construction and then attaching fine print in microscopic font. So yes, one episode is enough for the basic idea. The tensor product of a k-linear function and an L-linear function is defined by multiplying their outputs. And the result is naturally a k plus L linear function. That is the core idea. Clean, useful, and pleasantly free of commuting diagrams, a rare day of mercy.